Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1 and same chapter partial derivatives, and today's topic is partial derivatives of first order. As we have seen in previous lecture what is the partial derivative of first order, but in this topic, that means in part 2, we are using only differentiation formula and its rule to solve the example. So let's start with the first example. Okay, first example is find del f by del x and del f by del y for the given function f of x y is equal to e raised to minus x into sine of x plus y. So let's start with the solution. First we will write down the given function f is equal to e raised to minus x into sine of x plus y. First we will find del f by del x, that means differentiation of given function partially with respect to x, and we know that what is partial derivative. A partial derivative, that means whenever we are differentiate with respect to one variable, we treat other variables as a constant. So here we are differentiating with respect, we want to differentiate with respect to x, so we treat y as a constant. So now apply del by del x on both sides. So f becomes del f by del x and del by del x of given function. Okay, now here we are differentiating with respect to x, and x is appear in both the function, so we will apply product rule here. And what is product rule? We know that the d by dx of u into v is equal to u as it is d by dx of v plus v as it is and d by dx of u. This is our product rule which already learned in previous standard, that means in 12th standard. So we will apply this formula. Now let's apply product rule over here. So we have, first we will remove this one. We have first e raised to minus x as it is and del by del x of second term plus second term as it is and del by del x of first term, that means e raised to minus x. So this is equal to e raised to minus x as it is, and del by del x of sine of x plus y is cos of x plus y, and by chain rule del by del x of x plus y, that means this angle. Okay, plus sine of x plus y as it is and del by del x of e raised to minus x. So we know that differentiation of e raised to minus x is e raised to minus x, and differentiation of this minus x by chain rule minus. Okay, now this is equal to e raised to minus x as it is, cos of x plus y as it is, and differentiation of this term, that means del by del x of x plus y. So let's have a look here. Del by del x of x plus y, that means we want to differentiate partially with respect to x, so differentiation of this x is 1, and whenever we are differentiating with respect to x, so y treated as a constant, so this y is constant and differentiation of constant is 0, so we have 1, and this 1 will not affect this term, so no need to write down, and we have this minus and plus will be minus and e raised to minus x and sine x plus y as it is. Now taking e raised to minus x common, we have, this is final answer of del f by del x. Similar way, now we will find del f by del y, that means differentiation of f with respect to y partially. At that time we will treat x as a constant. Okay, so let's have a look. First write down the given function f of x comma y is equal to e raised to minus x sine of x plus y. Now apply del by del x on both sides. We have del f by del y is equal to del by del y of e raised to minus x sine of x plus y. Here in e raised to minus x there is no y, so we can consider this function, this term as a constant, and we can take outside from the derivative. Okay, because this is partial derivative. Now differentiation of sine of x plus y with respect to y is cos of x plus y and del by del y of x plus y because of chain rule. Now e raised to minus x as it is, cos of x plus y as it is, and differentiation of this x plus y with respect to y is 0 plus 1, so 1. And by simplifying this, we have the derivative of f with respect to y. This is our final answer. So you have seen how we use first order partial derivative, okay, with respect to x and with respect to y. So to understand better, let's start with the one more example. We have one example. Find fx and fy for the given function f of xy is equal to this. Now we know what is the meaning of fx and fy. Okay, we have seen in previous lecture. This is the notation fx, that means del f by del x, partial differentiation with respect to x of function f. And same way fy, that means del f by del y. Okay, right. Now let's start with the solution. So here first we write down the given function which is given in the question. Now we want to first find fx, that means differentiation partially with respect to x. So apply del by del x on both sides. So f becomes del f by del x, and we can write this del f by del x as fx. Okay. Now we want to differentiate this function with respect to x, and x appear in numerator and denominator both. So we will apply product division rule here. And what is the division rule? So d by dx of u by v is equal to, in denominator whole square, and in denominator as it is, d by dx of numerator, that means u dash, minus numerator as it is, and d by dx of denominator, that means v dash. This is the formula of division rule, that means quotient rule, which already learned in school level. So we will apply this formula here. So we have in denominator square, in denominator as it is, and del by del x of numerator, which already we have seen. So differentiation of x is 1 and differentiation y is 0, minus numerator as it is, and del by del x of denominator, that means differentiation of 2x will be 2, and differentiation of sin y is 0. Okay, by simplifying, we multiply this 1 plus 0, that means 1, with this bracket, and 2 plus 0 means 2 with this bracket. So we have 2x plus sin y minus 2x and plus minus 2y, and denominator as it is. Now by cancelling 2x and minus 2x, we have remaining part sin y minus 2y upon denominator as it is, which is our final answer fx. Same way we will find fy, that means differentiation of f partially with respect to y. Let's have a look on the fy. So first we will write down the given function. Now we want to differentiate with respect to y partially, so apply del by del y on both sides. We have applied. Now y appear in numerator as well as in denominator. So here again we will apply quotient rule, that means division rule, and we know that what is the division rule. So in denominator square, in denominator as it is, and differentiation of this x plus y with respect to y will be differentiation of x is 0, because this time we differentiate with respect to y, so we will treat x as a constant, and differentiation of constant is 0, plus differentiation of y is 1, minus del by del x as it is, that means x plus y as it is, and del by del y of this denominator. So with respect to y, this 2x becomes 0, and sin y will be cos y. Okay, now by simplifying, we have 2x plus 2 sin y, sorry, 2x plus sin y minus this 0 plus cos y become cos y, and we multiply this cos y with x and y. By opening this bracket we have this minus, so sign will be changed, minus x cos y and minus y cos y, and denominator as it is. So this is our final answer, because there is no any term which will be cancel out or we can take together. So this is our final answer, Fy. So this is the process how we differentiate with respect to x and y partially. That means first order partial derivative. Okay, same as we have done in school level, but we have to just keep in our mind that whenever we differentiate with respect to one variable, we have to treat other variable as a constant. Okay. So now we have one more example. An example is find del z by del x if the equation yz minus ln z is equal to x plus y. Here defines that z as a function of two independent variables x and y. That means in this equation z is a function of x and y. That means x and y are independent variable and this z is dependent variable, and that the z is dependent variable that depend on x and y. So here only two variable x and y, and z is our function, and partial derivatives exist, it is mentioned. So now let's start with the solution. First we will write down the equation, that means yz minus ln z is equal to x plus y. Now here only we need to differentiate this given z function with respect to x only. So we will treat y as a constant, not z, okay, because z is our dependent variable. Now differentiating partially with respect to x, so apply del by del x of this term. So del by del x of yz, del by del x of ln z, and del by del x of x plus y. So whenever we differentiate partially with respect to x, so y treated as a constant and z is our function, so y constant as it is, and differentiation of z will be del z by del x, minus differentiation of ln z. So differentiation of log is, we know that 1 by z, and differentiation of z will be del z by del x is equal to differentiation of this x plus y with respect to x is 1 plus 0. So we have 1 plus 0 is 1. Now we will take del z by del x common. So we have this term del z by del x outside, and remaining y minus 1 by z in one bracket is equal to 1. So we will take this y minus 1 by z in the right side, so it will be goes to in the denominator, and by simplifying or by taking LCM, we have del z by del x is z upon yz minus 1. This is our final answer. Okay, so this example is taken because this function z is included in this given equation, that's why. Okay, so this is some kind of little bit different from first and second example. So this is the partial derivative of first order with respect to x and with respect to y. We are taking one more example. Now we want to find the fx, fy and fz for the given function f of x comma y comma z is equal to x plus under root y square plus z square. Here three variable we have given and three variable are independent variable. So we can differentiate partially with respect to x as well as y and as well as z. Okay, so let's start with the solution. First we will write down the given function f is equal to this. And here no need to write down this x, y and z, because this x, y, z shows only this given function f is a function of three independent variables. So whenever we are writing we are starting with the solution, no need to write down this x comma y comma z. Now first we will find fx, that means partial differentiation with respect to x. Okay, so apply del by del x on both sides. So we know the differentiation of x will be 1, and in this term there is no x. So this entire term becomes constant, and that's why its derivative is 0. So 1 plus 0 and final answer is 1. So we have fx is equal to 1. Now we want to find fy, that means partial derivative with respect to y. So we will apply del by del y on this function. So del by del y. Now here we are differentiating with respect to y partially. So this x is treated as a constant and this z will be treated as a constant. So differentiation of this x is 0 here, and differentiation of this term. Now what we will apply? We will apply formula over here, and which formula? So d by dx of root x, under root of x, and we know the formula of under root of x is 1 upon 2 under root of x, and differentiation of x with respect to x is 1, so no need to write down this one. So we have formula, we used this formula already. So under root of y square plus z square will be 1 upon 2 under root of this, and differentiation of this y square plus z square. Okay, so now we are differentiating with respect to y, so differentiation of y square is 2y and differentiation of z square is 0, so we have 2y only. By cancelling this 2, we have remaining part is our answer, that means y upon under root y square plus z square. Same way we can differentiate given function with respect to z partially. So write down first f, and we apply del by del z on both sides. So differentiation of x will be 0, and this z is in a root, so we will apply same formula, 1 upon 2 under root y square plus z square, and differentiation of y square plus z square is with respect to z is y square 0, and differentiation of z square will be 2z. 2 cancel out, so remaining part z upon under root y square plus z square is our final answer. So in 3 independent variable we can also differentiate partially, okay, with respect to x, with respect to y, and with respect to z. These are the some DIY, that means do it yourself, that means your practice example. We have to find all first order partial derivative, that means if function with two variable x and y, so you have to differentiate with respect to x and with respect to y, and if function is with respect to x, y and z is given with three independent variable, so you have to differentiate with respect to x as well as y and as well as z. Okay, so that means all first order partial derivatives. So these are the example number 1, 2, 3, 4. So many example we have, just you have to solve by yourself. If you practice this sum, then and only then you will understand next lecture better. So keep practicing, solve this example by yourself, and if you find any query, then you can contact me. Okay, so thank you for watching this video. Keep watching, keep learning, and before starting next lecture, please keep one thing in your mind: practice, practice and practice. Okay, thank you.